Let us now look into the first problem statement, which comes in divide and conquer. Out of the many sorting techniques that are available in the field of computer science, there are two sorting techniques which actually comes under this particular design technique called as divide and conquer. They are merge sort and quick sort. We will have a look at both the sorting techniques, but first we will proceed with understanding merge sort. Now, in the field of computer science, merge sort is actually considered to be an efficient, general purpose, comparison based sorting algorithm. Remember, it is comparison based sorting algorithm. Most implementations actually produce a stable sort. That means the order of equal elements is same both in input and in output. Merge sort is a divide and conquer algorithm that was actually invented by John von Neumann way back in 1945. A detailed description and analysis of this particular merge sort is actually available in the report that was prepared by Goldstein and von Neumann as early as 1948. Now, as I told you, merge sort is actually a divide and conquer algorithm which is based on the idea of breaking down the original list into several sublists. Now, this particular merge sort operates with three parameters, what is called as divide, followed by conquer, and followed by combine. Now, divide means it divides the n element of your original array into two sub arrays of almost half of the size. That means each of your original array, in the sense, each of the sub array which is divided from the original array, that will be half of the size approximately. In the sense, if even number of elements are there, then it will be half. If odd number of elements are there, then probably the first array will have one element more than the other, right? So that is called as divide. Now, when it comes to conquer, it sorts the two subsequences, that is the two sub arrays, recursively using the merge sort algorithm. And the final step is combine. What it does in this particular step is it merges the two sorted sub arrays to produce the sorted sequence or the sorted array. Okay. Now, the key points which we have to understand in case of merge sort is when the sequence has only one element, I mean the array has got only one element, in which case there is no work to be done because it is already in the sorted fashion. And the second key point is the merging of the two sorted sub-arrays occurs in the combine step. That is the third step of the sequence, right? So the merge sort operates under three parameters or three constraints: divide, conquer, and combine. Okay. Now, the steps involved are: given set is split into distinct subsets, it recursively sorts the left part, it recursively sorts the right part, and finally it merges. Right? Now, before we try to understand this merge sort with an example, let us also understand that while comparing the two sublists for merging, the first element of both the list is taken into consideration, and while sorting in ascending order, the element that is of lesser value becomes a new element of the sorted list. Okay. Now, let us see how actually merge sort works. Now, to understand how merge sort works, let us take an unsorted array which is there in front of your screen. Now, I have an array of 8 elements, and the elements are there already in front of you. They are 14, 33, 27, 10, 35, 19, 42, and 44. Now, what I am going to do is I am going to apply the concept of divide. The whole array will be divided into two sub arrays. Now, since there are 8 elements, each of the sub array will have only 4 elements. That means the first sub array will have the first 4 elements, and the second sub array will have the remaining 4 elements. Got it? Now, the first sub-array consists of 14, 33, 27, and 10. Right? Now, this particular sub-array, I am going to again divide into another two sub-arrays where each of those two sub-arrays will consist of two elements. That means the first sub-array will now consist of 14 and 33, and the second one will consist of 27 and 10. Similarly, on the right side, when I look at the array which is having 35, 19, 42 and 44, I will have the first sub-array as 35 and 19 and the second sub-array as 42 and 44. Right? Now, again I proceed and divide. The first array is having 14 and 33. I will divide into two halves called as 14 and the other one as 33. Similarly, I will go with 27 and 10, then with 35 and 19, and finally I will go with 42 and 44. Now look at this particular slide. The top box has got 8 elements and the bottommost line or the bottommost row, we can say, has got 8 elements, but they are all not related to each other. That means they are not a part of one array as of now. That means right from the top, I have divided into equal half all the way till no more further subdivision is possible. You try to recollect, in the previous video, we had seen that this concept of divide and conquer, you keep on dividing the original array into equal half until no more further subdivision is possible. Right? Now, this is what is actually called as divide. Got it? This is called as divide. Now, the last row will also play a role in what is called as conquer. Right? Now, I will take this last row which comes as a part of conquer and I will have it here. Now, these are my 8 elements. And you know very well, the three methodology on which divide and conquer works is divide, then conquer, and then combine. Now, in this particular slide, right, what is there in front of you? I am going to do the combine business. Now, how does it works? I have already 8 elements in front of me. Understand? I have 8 elements in front of me. Now, I am going to combine these 8 elements. Now, when I am going to combine the 8 elements, I am going to take the first and the second element and then combine. Then I will take the third and the fourth element, that is 27 and 10, and then I'll try to combine. Similarly, I'll go to the last pair, which is 42 and 44, and then I will combine. So, let me come back to the first two elements, 14 and 33. When I make an attempt to combine this 14 and 33, I check whether the first element is less than the second element. That is, 14 is less than 33. If 14 is less than 33, that means algorithmically, if the first element is less than the second element, I am not going to do any swapping. And hence, here, since 14 is less than 33, I will retain the same order as 14 and 33. Now let me come to 27 and 10. I compare 27 and 10, and 27 less than 10, the condition is false, and hence in this case I am going to swap and I write 10 first and 27 next. Similarly, I do it for 35 and 19, and I also do it for 42 and 44. So this is how my first step of the combine methodology, combine point will work. Now after this, what I am going to do is, now here I have 4 sub-arrays with 2 elements each. Now remember, in the first row I had 8 arrays of single element. Now 8 so-called arrays of single element. Now I have 4 arrays of 2 elements each. Right? So I have reduced from 8 to 4 arrays. Now in the next step, from 4 arrays I will reduce to 2 arrays. Right? So what I will do is, in the next step of combining, I'm going to combine the two subarrays which consists of 14, 33 and 10 and 27. Now what happens in this case is, just before coming to this particular example, I had said one statement that while comparing the two sublists for merging, the first element of both the list is taken into consideration. And while sorting in ascending order, the elements that is of lesser value becomes a new element of the sorted list. And this particular procedure is repeated. That means what? When I am trying to compare the first array 1433 with the second array 10 and 27, the first element of the first array is compared with the first element of the second array. Please understand, in the first array, the elements are already sorted. In the second element array, the elements are already sorted. So now I compare 14 with 10 and I find 14 less than 10 is false. So I will swap. I will swap 10 and 14. That means what actually? Swapping means I will ensure the element 10 is placed before 14. That's the meaning of it. And hence what happens? I will get part and partial new array called as 10, 14, 33 and another array as 27. Okay. Then what happens? I am going to compare 14 with 27. Right? Remember, 10 is before 14. Now I am going to compare 14 with 27. I find 14 is less than 27, so I am not going to do anything. So my second element of the next array will be 14 only. Right? So the first two elements of the next merged array is 10 and 14. Then what happens when I am not doing the shuffling? I will increment my counter of the first array and now the counter will go to element 33. And I will now compare 33 with 27. 33 less than 27 is false, and hence what I will do is I will shuffle 27 and place it before 33. Understand? I will place 27 before 33 and hence my array looks like 10, 14, 27 and 33. It's merged into one single array. So this is how my array looks like. Similarly, when I proceed to the next side, the right side where I have 19, 35 in one subarray, 42 and 44 in another subarray, I check 19 with 42, there is no change. I will compare 35 with 42, there is no change. Then since the first subarray is over, I don't need to worry much about the second subarray because you know the elements are already in sorted fashion, and hence what I do is I retain like this. I have 19, 35, 42, 44. So now you see you have two subarrays each having 4 elements. Again, this is a part of combine. I proceed further and now what I do is I implement the same concept. I compare 10 with 19, no change, 14 with 19, no change, 27 with 19 and I put 19 before 27. Got the point? And hence what happens? I will get this particular array in the sorted fashion. Got it? Now let us see how the merge sort algorithm looks like. Now this is how the merge sort algorithm looks like. I may not throw much light on this particular example. I have already on this particular algorithm. As a matter of fact, I have explained you the example how merge sort works. So my suggestion is try to go through and understand the algorithm behind it and then try to develop a program in the programming language that is asked for you. The program can be developed either in C or C++, but my suggestion is always whenever you are trying to code data structures or algorithms for the first time, C would be a most ideal programming language. So I have algorithm merge sort here, right, where it takes 3 parameters, A, which is an array name, followed by low and high. So here, if the decision control structure if is satisfied, then the control goes inside. You are trying to figure out the middle element and then you are going to call the merge sort 2 times. The first time you have the parameter as A, low and mid, and the second time it is A mid plus 1 high. Now why you want two times? Because the first time you are calling the merge sort algorithm, right, this is for the left subarray, and the second time you are calling it as for the right subarray. Now these are the two lines where you say the call is actually recursive in nature, right? And then you call the algorithm or the function merge with three parameters, which is basically responsible to merge your arrays, right? So the algorithm merge is there in front of you on the screen. Just have a look at it. Now let us proceed with the analysis of merge sort, right? Before we wind out with understanding the time complexity, let us try to understand the analysis of merge sort. Now it is clear from the algorithm and the example that we have discussed that the problem instance is divided into two equal parts, right? Now let us assume that the number of items in your original array A are integral multiples of 2. Okay, integral multiples of 2. That means n is equal to 2 to the power of k. That's what I mean by integral multiple. N is equal to 2 to the power of k for all values of k greater or equal to 0. I repeat, n is equal to 2 to the power of k for all values of k greater or equal to 0. In which case, the recurrence relation for this algorithm is written as follows. T of n will be equal to 0 provided n is equal to 1. That means sorting is actually not required. On the other hand, since it is divided into two halves, that's what I said, that two equal parts. So T of n will be T of n by 2 plus T of n by 2, 2 times, plus n otherwise. Otherwise means for all values of n which is not 1. Now what is the significance of this? The first T of n by 2 is actually the time required to sort the left part of an array. The second T of n by 2 is actually the time required, okay, to sort the right part of an array. And n is nothing but the time required to divide and merge one instance of solution with n elements. Okay, now this is what you actually mean by analysis of merge sort. Now let us proceed further in understanding the time complexity of merge sort. Now you know very well that the general recurrence relation for divide and conquer is T of n is equal to A multiplied by T of n by B plus f of n. On the other hand, the recurrence relation for merge sort is given by 2 times T of n by 2 plus C of n, right? Now, when you map this with respect to the master's theorem of solving recurrence, it is clear from the above relation that the value of A and B are 2, right? And hence f of n will be Cn, which is nothing but C to the power of D, and so the value of D is 1, right? Now substituting these values of A, B and D in the recurrence relation, right, it is evident that the second relation A equal to B to the power of D, try to recollect the three relation which we have seen in the master's theorem. Now, out of those three relations, it is evident that the second relation A equal to B to the power of D holds good in this case of merge sort, and hence the time complexity is given by T of n is equal to whatever it is there, theta of n into log of n to the base 2. And hence we prove that the time complexity of the merge sort is given by T of n is equal to theta n multiplied by log of n to the base 2. Now this is how the time complexity of the merge sort algorithm is found out. Now before we wind out, let us see the advantages and disadvantages of the merge sort algorithm. As it is there in front of your screen, the advantages of merge sort algorithm is it is a stable algorithm, It can be applied to files of any size. The complexity is efficient compared to other algorithms. The disadvantages are it uses extra space, hence algorithm is not in place. Due to recursive in nature, it uses more memory in stack. Obviously, you have seen in data structures that recursion occupies more memory capacity, and it is slower compared to other sorting algorithms for smaller tasks. Obviously, right, deciding which sorting technique to be used, one of the important parameter to be considered is the value of n. That is nothing but your input size. And for small set of elements, if you use merge sort, correct, then it is considered to be the most inefficient sorting technique, right? Because we don't use sorting techniques like merge sort, or as a matter of fact quick sort, when the input size is so less, right? Now this is all about merge sort algorithm. In the next video we will see the quick sort algorithm.